This is part 3 of lesson 3. So we're going to determine whether a given argument is valid or not. So before we proceed with part 3, let's review what part 1 and 2. In part 2, we talk about biconditional statement. We determine whether a given statement is true or false. And then in part 1, we talk about conditional statement and converse, inverse, contrapositive, conditional, and the conditional. And we said that the contrapositive and the conditional are equivalent. The converse and the inverse are also equivalent. So now let's go back to lesson 3, part 3 here. So in part 3, asked to determine the whether an argument is valid or not. So here, list below is to review the standard form for a valid argument. First one is called the modus ponens. In this one here is kind of like the conditional statement. So in conditional statement, we said that P implies Q is true. It's only false if I have true followed by false. So here, I'm telling you P implies Q is true already, right? This is a true statement. So if this true statement, I know second part tells me P is true. If P is true, the first one is true statement. There's only one conclusion I could make. Q must be true. So that's why this is the first standard form. The second one is called a modus tollens. In the modus tollens here, I have P implies Q, and then have not Q. So P implies Q is true statement. Again, we assume the argument here, this is a true statement. Is true. Well, I know not Q is true. Well, P implies Q is true. Not Q is true. Well, there's only one conclusion I could make. That means not P is true. Notice that P implies Q and not Q implies not P. It's just the contrapositive of each other. And we said that's why this is true. Okay, so that's why we make this conclusion. So this is kind of just contrapositive. The third one, the law of syllogism. Well, let's look at that one here. P implies Q and then Q implies R. If P implies Q is true, and know Q implies R is true, well, logically, there's one conclusion I could make, which is P implies R. Again, this kind of reminds me of the transitive property that we use in algebra class. Next one is the disjunctive syllogism. So first, the first premise is that P or Q is true. Well, P or Q is true tells me either P is true or Q is true or both is true. Both are true. Well, the second line here, it tells me that the negation of P is true. Well, if the negation of P is true, that means P must be false. So to make the first statement a true statement, Q must be true. So therefore, the conclusion is Q. So these four here are the standard four valid argument standard form. Now the one on the right hand side here, false. You cannot use it. That's bad. Okay, don't do it. So which is one is a converse, one is the inverse of the given one. So I say don't do it. I'm gonna cross it out. Let me make it out. Just say don't do it, so you can see still. Okay. Now let's look at an example. Example 3. Determine whether the following argument is valid or invalid using a truth table and standard form. So here, I'm going to use the standard form first, and then I'm going to do truth table. That's a good review for what we've done. First, before I do any work here, I need to have some notation. I'm going to define my terms before I use them. So it's very important that you define your terms. What stand for what? So one common mistake that C students make is that a lot of them just use PQ, but I don't know what PQ stands for. Or you can use any letter in this case here. So whatever letter you use, define them. So I'm gonna let A stand for arrive before 8 a.m. F for I will make a flight. And then P for I will give a presentation. So based on that, let's translate this argument into symbolic form. So first one, I noticed that if I arrive before 8 a.m., then I will make the flight. Well, if and then is a conditional statement. So I'm going to have conditional. So I know that it's going to be, it looks like this. I arrived before 8 a.m. Well, I arrived before 8 a.m. We use the notation A to represent that. I will make the flight. We use the notation of F for that. So the first line, the first premise is A implies F. So first one of my argument here, my first piece of, think of it as your evidence that you're going to use to make a conclusion. So first piece of premise, so I have A implies F. That's the first line. Second one, if I make the fly, then I will give the presentation. Again, I see that it's if and then. So it's a conditional statement, if, then. And I see that I make the fly. Well, making the fly, I make the fly is F. I use F to denote that. I will give the presentation. I give the presentation, I use P for that. Okay. So F, this tells me F implies P. So my second piece is F implies P. Now, therefore, here, this is the conclusion. Tells me this is the beginning of this is the conclusion I'm gonna make. So I'm gonna draw a line here. Okay. Therefore, I'm making the conclusion. Oh, the conclusion. I have, what kind of conclusion do I make? Let's check. Let's see here. So I arrived before 8 a.m. Again, this part here, arrived before 8 a.m. is A. I use to denote A. Then I will give the presentation. I will give the presentation is F. And I also see that's if and then. So it's a conditional statement. So A implies F. A implies F. And that is the symbolic form for this argument. Okay. So while symbolic form, does it look familiar? Does it look like one of the standard forms that we discussed earlier? So A implies F, F implies P. It's just the standard form for the law of syllogism, this one over here. So we're going to use that one. So by law of syllogism, we know this is a valid argument. So I say, let me write it. So conclusion. So this is a valid argument by the law of syllogism. This is a valid argument. Okay. So this is called the standard approach. We finished the first approach. Now let's with the same example, let's do make a conclusion, do a standard, use the truth table to come to a conclusion. To see if we still have the same conclusion. We should have, because we know this is a valid argument already. So let's do it. Well, to set up the standard form, using a truth table to make the argument, I noticed that in my symbolic form, I have three components. I have A and F, P, three components. That tells me n is equal to 3, right? So n equal to 3. If n is equal to 3, each component has two possible outcomes, true, false. So 2 to the third is going to give me 8. So I need 8 rows for my truth table. So that's why I have 8 row here. Oh, there's some typo there. So this should be 5, row 5, row 6, 7, row 8. Okay. So I determine I need 8 row. Now to set up using truth table, I need to set up my premises. I write down my premises in one on the right hand side. Then I also write down my conclusion. So I need the first premise, which is the first piece of your evidence that you use to make the conclusion. You can think of that way. So is A implies F. I'm gonna leave some space, okay? And then the second piece is F implies P. Let me write it a little better. F implies P. And my conclusion is A implies F. Okay. Now let's set up a standard form. of the truth table. Now here is just a matter of making truth table. So we said for standard form, the first component here is always half true, half false. The second one alternate half of the previous one. What this means is I would have true, true, then false, false, true, true, false, false. And the last one, I'm going to alternate. What do I have? Half the previous one, which is true, false, true, false, true, false, true, false. Now I just have to find the true value for the both premises. So first one, I have A implies F. So that means I'm looking at only the first two component here. We said A implies F. The conditional is only false if I have true followed by false. So let's just write a true value out. Since this is very direct here, there's no negation, nothing needed. I could just directly using the first two column to fill in the conditional directly. So first row I have true, true. Well, true, true is true. So I have a true. Second two I have true, true. So true. Third one I have true, false. We say true, false is false in a conditional. So this is false. I have true, false. So false. False, true is true. False, true is true. False, false is also true. Okay, that is my first premise. Now I could label column 1 here, and again for ease of discussion. Second premise is P. F implies P. F implies P is just the second and the third column here. So here I could just directly using this table to these two columns to find the conditional right here. So let's do it. First one is true, true. So it's true. So true, false is false. True, false is false in a conditional. So false, true. So false, true is true. And false, false is true. True, true here is true. True, false is false. False, true is true. False, false is true. And I'm going to make that my column 2. Okay. Now, similarly, I can do column the conclusion in the same way. The conclusion, I need to look at the column 1 and column 3. You could bring the value of A and F over under A and F and then make the conclusion, or you could just directly look in the left here. So for the first row, I have a true, true. So therefore, the true value is true. The second one I have true, false. So it's false. The third I have true, true. So it's true. The fourth I have, make sure you look the correct one here. True, false. Also false. So true, false. Let me highlight so we go along. So again, so this is true, false. So therefore it's false. And true, true is true. True, false is false. Let's review that. So next row is I have false, true. False, true is true. I have false, false is also true. I have false, true. Okay, still therefore is true. I have false, false. Well, false, false is also true. Now I'm gonna just erase this highlights. I don't need them anymore. And make it a little easier to read. Okay, and make this my column 3. I complete the truth table. Well, but what does the truth table tell me here? Remember, my goal is to determine whether this argument here is valid or not using truth table. So I'm not done yet. So let's see. Well, we call that of argument is valid using truth table is if whenever the premises are true, my conclusion must be true. So first thing, I need to locate the rows where both premises are true. So let's look for it. The rows that both the premises are true are, let's see, the first row, I see that the both premises are true. And I see that row this row here, which is row 5, both premises are also true. I see row 7, both premises true. Row 8, both premises are also true. So whenever both premises are true, my conclusion have to be true. If one of them is not, then the argument becomes invalid. So let's check. First row, both premises true. Let's check the conclusion. Well, the conclusion is true. Oh, we're okay. So it's valid so far. In the fifth row, I see both premises true, and my conclusion is also true. So this is valid. My last two rows, the both conclusion is also true. So each one of the time when both premises true, my conclusion are also true. So this argument is valid. So let me write it. So first, let's make a note that. So note that the only row I need to consider is only the row where both premises are true. I don't need to worry about the rows where the premises are not true. So let me write the note. Let me write a note first. So note. The only row in which all the premises are true are let me list them out first. 1, 5, 7, 8, and in each of these rows, the conclusion is also true. So therefore, let me use therefore, the argument is valid. Okay, let me zoom out so you see the whole truth table. Okay. So in this example 3, we use both approach to determine whether argument is valid or not. The first one, we did a standard form approach, and which is using the 4 standard form that we know. And second one, we did a truth table approach. Thank you for watching the video. See you next time.